To calculate the electrical load for a multifamily dwelling unit, we need to consider several factors. Firstly, we calculate the total wattage of the appliances. Secondly, we apply demand factors as permitted by the National Electrical Code, NEC. Thirdly, we determine the service size. In this example, we have 40 units, each 1,000 square feet, with an 8 kilowatt range, a 2.5 kilowatt water heater, a 1200 volt amp dishwasher, a 600 volt amp disposal, and an 18 amp 120 volts air conditioner. There is no laundry equipment specified. Let's start by calculating the wattage of the air conditioner. The air conditioner draws 18 amps at 120 volts. To find the wattage, we multiply the amperage by the voltage, so 18 amps times 120 volts equals 2160 watts. Now let's calculate the total connected load for one unit excluding the air conditioner. We have an 8 kilowatt range, which is 8000 watts, a 2.5 kilowatt water heater, which is 2500 watts, a 1200 volt amp dishwasher, and a 600 volt amp disposal. Adding these together, 8000 watts plus 2500 watts plus 1200 volt amps plus 600 volt amps equals 12,300 volt amps. Since we have 40 identical units, we multiply the total connected load per unit by the number of units to find the total connected load before applying any demand factors. So 40 units times 12,300 volt amps per unit equals 492,000 volt amps or 492 kilowatts. According to the information given, all 40 units have identical appliances. Now, according to the question, it states we need to use 8 kilowatts plus 2.5 kilowatts plus 1.2 kilowatts plus 6 kilowatts plus 2.2 kilowatts, which totals 14.5 kilowatts. This value is then multiplied by 40, which equals 556 kilowatts. The air conditioner load is 2160 watts. Combining these two values results in 558,160 volt amps. To calculate the amperage at 240 volts, we divide 558,160 volt amps by 240 volts, which gives us 2325.67 amps. We now need to apply a demand factor of 8 to 2325.67 amps, which results in 1860.54 amps. Now 1860.54 amps is multiplied by 120 volts, which gives us 223,265 watts. Then divide by 127 volts to get the answer, approximately 1755. It is important to consult the latest edition of the National Electrical Code, NEC, for specific demand factors and calculation methods applicable to multifamily dwellings. Different sections of the NEC address various aspects of electrical load calculations, including general lighting loads, appliance loads, and motor loads. Understanding and applying these code requirements correctly is essential for ensuring the safety and reliability of the electrical system. The NEC provides tables and guidelines for determining demand factors based on the number of dwelling units, the types of appliances installed, and other relevant factors. These demand factors allow for a reduction in the calculated load, recognizing that not all appliances and equipment will be operating at their maximum capacity simultaneously. Ignoring any appliances such as laundry, heating, or cooling will change the outcome of the final calculation. Therefore, it is crucial to ensure that all loads are accounted for during the load calculations.